insights will emerge as you gather more information. But we'll get to that later. Yeah, that'll be coming on Wednesday. We've also got a hiding quiz. So the hiding quiz is going to be based on what I'm talking about today. Okay. And that's really right at the end of the course. By the time you're doing this quiz, you'd have done all of this stuff. It's really focused on this exercise though. So the tools in this exercise are what you're going to be preparing to use in the hiding quiz. Okay. I just kind of wanted to emphasize that. So this exercise is kind of important in terms of getting that done. It's not a hard quiz at the same time, you know. So, so today we're going to do alternate data streams or data streams and steganography. So I'm doing two PowerPoints, two related but separate topics. Okay. I like ADS. I think that's kind of interesting. Steganography is a very popular. It's a popular topic in forensics. There's a lot of coders who develop steganography because they just find it interesting. The exercise that I want you to do is this hiding exercise. I'll talk about that in a little bit here. Yeah, Stegosaurus. Yeah, pretty much. Yeah. I don't know if the root word is connected or not, but that I can't tell you. But they do call it stego. So, all right. So I'm going to start with alternate data streams because um, it's a little bit easy. They're both easy to understand, I guess. They're not that hard. Working with the tools. This is interesting because you already know NTFS, and it's just an aspect of NTFS which is not talked about very much. So we're going to talk about the generic concept of what a file system fork is, and we're not being specific when we talk about a file system fork. That's a generic term. Where they came from, and then how did Microsoft get tied up with them? Because they didn't always have forks in their file systems, but now they do. So, and then we'll talk about how this can be misused by malware writers and other people who are looking to conceal information. Okay, so we'll look at how it's used and how it's misused. Uh, Before I get going, any questions anybody has? I figure I'll before I really get going. If there's a burning question that you don't want to forget about, now would be a good time. Because once I get going, I'm like a train, right? I just don't stop. So, all right. Okay, so what's a file system fork? This is a way of associating data together, but actually storing them separately on the file system. Okay, so I may have, sometimes it's nice to keep your data kind of clean. Um, and maybe you'll want some resources that are associated with the file to be stored in one location on the disk and another set of data to be stored on another location on the disk, but you do want them to be linked to each other in some way. That's what a file system fork is, essentially. And this isn't a concept that came out of Microsoft. This actually belongs to Apple for the most part. I could say that they're the ones who own this more or less in terms of being a popular operating system that implemented forks. Okay. So if you have a file system that supports forks, then you can store metadata about the main stream or the main data within your system. It keeps other information. So things like the title of the file, the author, keywords, date and time of creation, who can access it. This is all metadata which in fact would be stored in the file allocation table. But another way of doing this is to actually store it in a separate file, which is associated with the main data. You know, they now forks don't have size restrictions beyond any other, just beyond the file system restrictions themselves. So I could have a resource fork that is larger than the original data. Okay, so it's not like, it's not like Twitter or X or whatever, where you can only have a certain amount of text, and that's the limitation of it. You could have binary data in a resource fork, you could have text data, and the limitation of the size of the file is just whatever the file system states as a limit for general files, you know? So in a fat file system, you might have a limit of 4 gigs, right? But I could have a 1 kilobyte text file with, a 4 gigabyte alternate stream or fork, file system fork. Okay. So the thing is, the main file associated with that resource is the one that's visible. The other ones are kind of, any other resource forks out of that are kind of behind the scenes. Okay. So this was how Apple worked with their file system, HFS. That's the hierarchical file system. They don't use HFS that much anymore. That's kind of their old school file system. And after that, they came up with HFS Plus, which was an improvement on it, kind of like going from FAT to exFAT, let's say. And now they're using something called the Apple file system, or Apple. I think it's called APFS or something like that. I can't quite remember what it refers to. But they've replaced their own file system. But back in the day, this is around the 1990s, really. They implemented resource forks in their file system. And so, they would put typed content for, say, a document into the main data fork, and then the other forks would have whatever extra information like fonts that you're using, things like that, right? Graphical content, all that kind of stuff. So the resource fork holds the metadata that's used by the operating system GUI, such as the file icon associated with the file, sounds, fonts, and boxes. This is all HFS and Mac. Okay. Now the problem was, if you go back in the day, um, back to the days of floppies and things like that, people would have to connect. They'd be using, let's say, Office on a Macintosh system, and they'd save their file to a floppy disk. Okay, and there were Mac floppies, Mac formatted floppies, and there were Windows formatted floppies. When you tried to copy from a Mac formatted floppy to a Windows formatted floppy, FAT did not support resource forks. And so you would always get these mangled files. Okay, if you're trying to go from Mac to Windows or Windows to Mac, it would cause problems, especially going from Mac to Windows. So when Microsoft decided to implement a new file system, NTFS, which is what the N stands for, a new technology file system, um, they decided, well, look, we're having these interoperability issues with Macintosh. Let's develop support for resource forks. And they just called it alternate data streams. That's their version of resource forks. So that's just a Microsoft name for that particular concept. Okay. So with NTFS, we have built-in support for resource forks, and you can't turn that off. It's a feature of the file system. It doesn't go away, and for backwards compatibility reasons, it's not going to go away. Okay. Unfortunately, it turns out that this gets misused more than it's used. Okay. So back in when they came out with Windows 2000, which was in, I think, 1999, Microsoft began using streams to store things themselves. So beyond just supporting Mac and transitions from Mac, they also started using it themselves for things like author attributes, title attributes, image thumbnails, little things. Okay. And that's pretty much where it stayed for Microsoft and their use of it. They do tag it for some security purposes. We'll get into that pretty soon here. But really, it's of minor use. They just use it occasionally for certain things. So when they introduced something called the attachment execution service, if you've ever downloaded an executable and you try and launch it, and it says, "Hey, this comes from the internet. You don't want to run this," that's the feature that I'm talking about here. Okay. Uh, when they introduced that, they decided to implement it with alternate data streams. Okay. So what they do is if you pull something down off the internet, it'll get tagged with an alternate stream, which indicates what security level or what zone it came from. In this case, that would be the internet zone. Okay. If I grab a file off of an internal server, it'll get tagged as just the intranet, our internal network. If I create something locally, it'll get tagged as a local file with an alternate stream that indicates that. And so that's one of the main uses that you're actually going to see with alternate data streams in modern versions of Windows. Okay. So the browser adds an alternate data stream to the file that stores a tag telling Windows what zone the file was downloaded from. And that file is called a zone.identifier file. Okay. So I'll give you an example of this. I just go over to my workstation, my forensic workstation here. So I launched Internet Explorer on this because um, I don't have Edge installed. And then it prompts me to install Edge, right? So I said, yeah, okay, go ahead and install Edge. Um, and then I downloaded that little stub file. Okay, so I'm just going to go over to my downloads, and you can see I've got the Microsoft Edge set up. I haven't run it yet. Okay, if I click on this and I go to Properties, you can see that under Security, it says this file came from another computer and might be blocked to help protect this computer, right? And then I have the option to unblock it. Okay, I'm not going to do that, but this is what we're talking in terms of security. This is this feature which is making use of alternate data streams. Okay, so I'm just going to cancel that. I'm going to go back over to my downloads, and just in the command prompt, I'm going to do a dir. Right, so I'm underneath my downloads here. I can see my Microsoft Edge setup.exe, right, which is a small file. But I can't see those, the alternate stream that we're talking about, right? However, there is a switch. If you do dir slash question mark, if you look, let me just press enter here. If you look at the slash r switch, it will display the alternate streams of the file, okay? So I'm just going to CLS. I'm going to do a dir slash r. And when I do that, instead of showing me the one file, so let's just show the old dir again. Instead of just showing me this one file, I see the file, and along with it, I see that there's a zone identifier file. Okay, that's the alternate stream that we're talking about. This is how Microsoft uses it to kind of tag something, right? Now, if you know what, I'll come back to this in a second. So let me just continue on with the talk here. But put a pin in this, and we're going to come back to it. So we've got this zone identifier file, right, which is telling us, first of all, the system it didn't come from this system, like the file didn't come from this system. And second of all, it tells us kind of how wary we should be by giving it a certain level of trust, right? So there's internet, local intranet, trusted sites, and restricted sites. So when I'm using my browser, and that could be Edge too, it'll tag it with one of these, okay, or local computer. That's the other option. Okay, and then it'll be treated accordingly. So if you kind of break that down into how is this implemented, really there's just a value stored in the file, which is either it's 0 to 4, and if you're dealing with something that's coming from the internet zone, it's going to have a value of 3. And when the operating system looks at this, it's going to be like, okay, we don't necessarily want the user to run this, so we're just going to kind of warn them that it might not be a good idea. Whereas if it came from the local computer, it's going to have a 0, 1 or 2. Those are all trusted, right? So you won't get a warning in that case. Okay. If you have a restricted site zone, you'll also get a warning. Yeah, this is a bad idea. Okay. Now, even if the file is moved from one NTFS file system to another, this data will be preserved because the operating system will see, oh yeah, okay, so each of these file systems both support streams. We're going to move the data over. Okay. If you try and copy this to a FAT file system, you're going to get a warning that some metadata will be lost in the transfer. Okay. So FAT still doesn't support streams, and that can actually be a good way of cleaning out uh, resource forks in Microsoft. So if you have a bunch of files that have all this zone data, you can just copy them to a FAT file system and copy them back, and you've laundered them essentially. You've cleaned them up. Okay. So we'll look at that in a little bit. So with NTFS, every file has a default $ data file. Okay. That's the first one that we saw with MS Edge. It's the very first file. That's the actual exe. That's the main data, right? And then you can have as many alternate data files as you want. You just have to append a colon followed by an extra name on top of that to create an alternate data stream. Okay. Now, to say that this is secretive, it's like an open secret, you know? It's TMI, like it's too much information for most casual users. They don't really care about this level of detail. But it's always been here, and security people have known about it for a long time. Okay. The thing is, there was no mechanism up until Windows 7 to actually display any of these. So if you had a resource fork, if you had an AD stream, uh, it was very hard to know that you had one. This dir command that was only implemented with the /r switch as of Windows 7. And prior to that, directory listings wouldn't tell you that this even existed. Okay, so you had to go to third-party tools in order to figure that out. And this is why a lot of malware writers were kind of like, great success. So they'd program the use of alternate streams into their malware so that they could hide things very effectively, right? Nowadays, we have the ability to use dir, but we also have PowerShell, which gives us access to streams as well. Okay, so let's just go on back to that system. So if I do get, no, I don't want to do that here. I want to do it in PowerShell. So let's go to downloads. That's not useful. Slash users, to Saunders, downloads. All right. So if I do a dir, I can see that the file is there. But if I do get dash item, let me just see what that command fully is. Just a dash stream. Okay. So I'm going to do dash stream star. Okay. Now it'll show me my $ data stream. So that's the main one, right? And it'll show me how long it is. And then we've got that zone.identifier. So that's in PowerShell. That's the same thing as what this is doing. Okay. Except it's giving us a little bit more information maybe. But that's about it. Now, if I want to actually access the zone.identifier information, um, I can either do it with Notepad. That's one way. It's a bit manual. But with PowerShell, I can actually extract it into like a variable, right? So if I just call it, let's say, $zone. So I want to do that. I'll spell it funny. Zone is equal to get dash content, right? Um, Microsoft dash stream. And then I'm just going to copy zone.identifier and kind of hope that I got all the switches correctly. Oops. Darn it. Hold on a second. I fat fingered it. Okay, so I've gotten content from zone.identifier, and I put it into the variable. Now, if I just spit out the variable, I should get the content, right? We'll see how that goes. There. So here it is. There's the, it's kind of like an INI file. There's this section, zone transfer, zone ID equals 3. If we go back and we check that list here, that's telling us it's the internet zone. So it's as simple as that. That's all the data that's actually being stored in that zone identifier. Okay. Um, so it's not, it's not too complicated, but it's a simple way for Microsoft to tag things. Now, if I want to delete that, I think what I have to do is I think I just have to empty it out. But I'm going to show you how to do it with Notepad. So if I run Notepad, and I'm just going to specify the file name here. So I'm going to copy that. I'm not going to include the colon $ data. Okay. So I want to get Microsoft Edge setup.exe colon zone.identifier to specify what stream. And when I hit enter, I get the same content, except now it's in Notepad, right? And if I want to, I can just set that to 0, save it. And now if I rerun that, it's kept, okay? Now if I go over to the folder, let's just see what it has to say. Oh, it's still saying that there's something wrong with it. Interesting. So let's try and delete that. I'm going to go there. I'm just going to get rid of all of this stuff. Now, this might not allow me to get rid of it. We're going to see. Yeah, look. Yeah, so if I do a dir, it's still there. So let's just check whether it's not blocked anymore. So uh, even though I didn't get rid of the stream, I've made it 0 in terms of size, and now it's no longer enforcing the blocking of the file. Okay. Now, if I wanted to, I could also set content. And then just hit enter. And let's just see. Yeah, it's still there with the size of 0. So to get rid of it, I might have to delete it or something like that. But it's really doing nothing at this point. I managed to disable it. Okay. Okay. Oh yeah. Let me do that. That's the other thing I wanted to point out. So I kind of mentioned fat file systems don't actually support the use of these streams, right? So what I've done here is this is just my downloads folder. And here I've created an encrypted container, which is a fat file system. Okay. So this is my K drive. If I go into the properties, it's just FAT32. Okay. So if I take this MS Edge setup, I'm just going to go copy it over here. And then I'm just going to go and copy it back over to my desktop. Okay. And now if I go over to my desktop, nope. And I do a dir/r, it says Microsoft Edge setup.exe. There's no alternate stream. So what happened was this fat file system just kind of cleaned it out. And when I copy it back over, even though I'm on an NTFS file system here, it's lost all of that data. Okay. You'll get the same thing happening if you put something into a VM and then you copy it back out. Any alternate streams will not get copied over. Same idea if you send an email as an like you send an attachment. If there was an alternate stream on that file that you sent, well, email doesn't understand NTFS, and so any streams are lost. Okay. So if you're going NTFS to NTFS, everything gets preserved. But if you're using something, like you're transferring data, um, I'm not even sure. I think OneDrive is okay, but if you're moving to another file system, if you're using an application like FTP, it's not going to keep that information. Okay. Okay, so I did a set content. This is just, oh, yeah, that's just setting the content. I already did that. Get item. That's pretty much what we did already. Okay. Now, so I think I covered um, PowerShell well enough there. PowerShell is a good way to interact with this stuff because you can actually script it. The command line, it's good for visual, like just CMD. It's good for visual inspection, but it's not that useful for scripting. Okay. Now, because historically streams have not been easily visible, malware writers have used it to hide things. Okay. That game it's not quite up, but it's like, it's a bit more subtle now. It's harder to hide this stuff. So in the old days, antivirus wouldn't even look for alternate streams, right? And so it was a great way to hide malware in a way that the AV just wouldn't detect. Nowadays, they're onto that. They actually do look for streams and they will scan them. Okay. But what they used to do was they'd attach their malware to innocuous files or even essential files, right? So you could tag it on to like command.exe as an alternate stream. Within that, you can actually have code that you could actually run, which would not be very easily detectable. Now, one of the things is that when you create one of these and you look at the file size doesn't change the main data set file, right? That also makes it a little hard to notice. So let me just give another example of that. Let's say we go over to the C drive. I want a fairly large file, so let's go for offline. Um, those aren't that big. Well, let's just say volatility, right? Nope, I don't have that there either. Okay, that's too small. Darn it. Okay, I'll just grab something big. Hold on a second. So, maybe an ISO. I don't want too big an ISO. Let's see. Let's do Ubuntu 20. Okay. So we're going to copy that. Oops. And copy that. And we're going to put it into our virtual machine here. So I'll just put it under UMIT20. No, I'll put it under files. Offline. There we go. Okay, so let's go to cd/offline, do a dir, and I've got that Ubuntu file. Now I'm just going to make a new file. So I'm going to say echo hello and pipe that or redirect that into demo.txt. Okay. Now let's just go on over there and check this out. So we've got our demo file, 1 kilobyte, really small, right? Okay. Now what I'm going to do is I think I have to use the command type. I'm going to type Ubuntu. I'm going to redirect it into demo.txt colon uh, ubu.iso. Okay. So what it's doing is it's showing all the output of Ubuntu 20, and then it's redirecting it into an alternate stream called demo.txt colon ubu.iso. Get them all. I'll keep talking while it does that. It might take a little while. So that's kind of what I'm doing here. I'm doing echo or type, right? So type can get the content from a file. Echo lets you create a file. And then you can use redirection so that instead of it showing up on your screen, you can redirect it into a file, right? So if I want to type the content of that ISO, I can then redirect it into whatever file I want. And I need that colon because that's how we interpret what an alternate stream is, okay? So for example, echo, I'm invisible, redirect it into file1.txt colon hidden file.txt. Now, Windows Explorer is not going to show us anything but file1.txt. Okay? Uh, let's just check this out again. Should be done. Yeah. Okay, so if I look at this and I give it a little refresh, even though I've put 900 megs of data into the alternate stream, I don't see anything when I'm looking at demo.txt. It still shows as 1 kilobyte. If I actually open demo, it still looks the same. Okay. If I go into the properties, this is where you can potentially notice it because even though the size is 8 bytes, the size on disk is 900 megs. Okay. So here is size on disk is where it's actually giving you some information that not everything is what it seems. Okay. Now, what happens if you want to go and extract that binary file from the stream? That gets a little tricky. Notepad can't extract binary data, right? Uh, so let me just delete this, or I'll just copy the name. Oops. No, I don't want to do that. Ah, right. Hold on a second. Doo, doo, doo. Okay. So I'm just going to delete that puppy, and we're going to try and restore it. Okay. The way that you could do that is with a hex editor. I'm going to run that as administrator because I think the permissions on the folder are required min rights. Okay. Now, oh no, I can't do it that way. Sorry. I've got to call on it through where it's installed. So I'm going to go to C drive. I think program files. Do I have HXD here? No, I don't. So program files x86. There we go. I need to get that binary file, right? So I want this path, and I'm just going to do maybe in quotes slash hxd.exe. So I'm going to call on it through the command line, and I'm going to say I want this file. Okay. If I tried to browse for this, using HXD, like if I just ran it like this, and then I just go File Open, I'm not sure that I'd actually be able to get that data. But if I run it through the command line, it will actually get the data for me. Okay? So I'm going to do File, Save As, and I'm going to go back to offline, and I'm just going to call it, I lost that copy, so I'm going to call it ubu.iso and save. Now, the nice thing with a hex editor is that it's built, it's designed to work with binary. So, if I'm trying to get text, I can use Notepad. But if I want to extract binary data, this is a good way to do it. Okay. So if we just go back to offline, here we've got our ubu.demo, and you can see that it's the correct size. Okay? So there are different ways to get that information, but a hex editor is a good one. Okay. Now, another example here, in this case, they're making a directory called things, okay? And you can actually associate a directory with alternate data streams. So if you cd into things and then uh, you create some text and you redirect it, so echo hide stuff in things, redirect into colon hide.txt, the folder things is going to have an alternate stream called hide.txt where you can actually store content. Okay, and I think that's probably one of the cleverest ways to hide things because I'm not sure if folders get checked a lot for alternate streams. Okay. So, like we said, the directory command can see the alternate data streams these days, and PowerShell can do it, so it's easy enough to check, right? There are third-party tools that can also do this. So sysinternals had a stream command, which would do that for you. They had that around for a long time, even back in the XP days. And there's lads from Frank Hine software. We don't really need them as much anymore, but they are there in a pinch, right? So if you're on an XP system, if you're on a Windows, Windows Vista, something old, you could still get this information. Okay? So I think I've done enough of this in terms of demos, really. Now, it used to be the case that you could actually put an exe into an alternate stream and you could run it directly using the start command. Windows got wise to this and blocked it. So, at least since Windows 7, you can't really do that. But it is still possible. You could do a few gymnastics and get that exe to run still. Okay, you'd have to pull it out of the alternate stream and then execute it, but you could pull it out into RAM, for example, and then execute it from there. Okay, so malware writers are still using this as a way to kind of smuggle their data and store it in a way that's not that easy to detect. Okay. Any questions about streams before I move on to the next topic? Just gonna take a sip of coffee here. Okay. Next one. This is a bit more like I'm just going to talk about it. I'm not really going to demo much, but you'll get plenty of chance to play around with it yourself in the exercise here. This is steganography, which is a fancy word for hiding stuff in other stuff. Okay. Which I guess, that's a little clear. Well, no, I don't think it is clearer than saying hiding stuff in other stuff. But, people like to sound smart. So, okay. So, uh, I'll skip that intro bit there. Where does this come from? The word is from Greek. It means hidden, basically hidden messages, hidden writing. Okay, and it's the idea of hiding information in plain sight. We've been doing this for hundreds and hundreds of years. So it's computers have really, made that uh, explode in terms of usage. But we've always been trying to hide information in various ways. And so, this is not new. It's just that with computers, we found different ways to do it. Okay. So typically, you have to have some kind of carrier, uh, which looks innocuous, right? And then you have to have the actual data that you want to send. So if in the old days, they would like tattoo something on a person's head. They'd shave his head, tattoo, let the hair grow back, and then the person would be the carrier, right? So it's old school, this whole concept. The idea of invisible ink, it's also a type of steganography. This is different from encryption because encryption actively blocks you, whereas steganography is really just a type of hiding. If you know enough, you can get into it, right? Um, Now, the way that you kind of double up on security is that you do steganography with encryption. So you encrypt your data, then you hide it with steganography, and that's often the way that it gets used. So another example of steganography prior to the advent of the computer age, they used to implement, they would smuggle messages in scarves by knitting Morse code into the scarves or the sweaters or what have you. And then it would not be obvious that there was actually a message there, right? And if somebody kind of patted you down or whatever, there's nothing to find. They'd have to understand how this information was being encoded, right? So that was something that used to be done back in World War II. Ladies would knit, um, they'd knit scarves or sweaters or what have you with the messages that were meant to be sent, and then some human would wear it across a border, let's say, or from one town to another. Now, in the computer age, what we really want to use is media files. And we use media files as the container for whatever messaging we want. And the reason that media files are good is because one, they take up a fair amount of space. Okay. Two, we have lots of them. So, if you think of how many pictures you have on your phone, um, those are a great choice if you have a lot of data that you need to hide away. Movie files are even better because they're bigger, right? And so nobody's going to notice if you have like, I don't know, like say a 1.5 gig movie. If you've added on an extra 100 megs to store a little bit of data in there, right? They're not really going to suspect anything. So it can be suspicious, but it depends how careful you are about it. So a lot of people who are like into, I say, child pornography or something like that, what they'll do is that they'll stuff their illegal content into innocuous looking files. Okay. And that way they have not necessarily plausible deniability, but it's not obvious that they're actually using this illegal material, right? They still have to be careful when they extract it, that they clean it up nicely so that if there's a forensic investigation, they don't get caught, right? And so that's usually where they do get caught. They don't do the proper cleanup. But actually finding those hidden files within other files is tricky. It's not necessarily that easy to do. The best way to do it, there's a few approaches, but the best way to do it is to understand the tool that they were using to do this stuff. And if you can kind of reverse engineer how that works, then you can create ways of detecting its use. Okay. So steganography, there's the two basic elements. There's the carrier, which doesn't have anything untoward about it, and then within that, there's a payload, which is presumably contentious in some way. So once you get the payload in the carrier, then you have your hidden message, right? Now, there's different approaches to steganography, and it depends on what kind of media you're using. So there's insertion, which allows you to shove data into a file, but when you're doing that insertion, it's changing the size of the file. Okay, so it's a modification which is noticeable. Uh, you do have to have some kind of separate application that will actually do this for you. and then you have to choose whatever kind of media files that you want to use. Okay. Substitution is a little bit different. What it does is it replaces content in the file. It doesn't add to it. Okay, it changes it. And so the file size is not going to change. The quality, let's say you're dealing with an image or a video, the quality may degrade a little bit. If you choose a careful amount of data stuffing that you do in, then the human eye won't notice the difference. But if you overdo it, you're gonna, let's just say it was an image. The image will look grainier and maybe have some weird artifacts in it, like just some pixels and stuff that don't look right. If you're doing sound, if you're stuffing data into audio, what you'd likely get is more and more background noise, like just like fuzz, that kind of thing. And so the more that you substitute in data, you're replacing legitimate noise with background noise, which is going to be noticeable the more that you do it. And with video, it's the same thing. You'll get these weird artifacts, kind of a digital graininess that's occurring if you overdo it. Okay. So typically, what they want to do is be rather conservative about how much of the file they substitute, so that they're not causing too much damage and it's not really that noticeable. So, for example, in terms of choosing your media, let's just say we're dealing with a digital picture. It's got a good resolution, 1920 by 1080. So that's a fair amount of data that you can replace bits with, right? Now, when you're dealing with bit depth, we typically use 32 bits these days. If you have an older image, it might be using less bit depth, okay? And so each pixel has fewer bits representing its color, right? The more bits you have, the more you can steal and reuse for substitution. Okay. So if you have 8 bits, you got 256 colors. I can shave off one of those 8 bits, the lower 8 bits, and I could replace it with something else. Okay. So I could use about 1/8 of the data in the file to actually substitute in another file, which means I could have a file 1/8 of that size that could fit into it. Okay. On the other hand, if I have 24 bits, then I'm using more data, but I can steal more bits essentially. Out of those 24 bits, I can reasonably take about 3 without causing a whole bunch of distortions in the image. Okay. The other thing when you're thinking about doing steganography, it's nice to have pictures which have kind of a uniform color to them. So black and white is actually kind of like grayscale is really, really good for steganography. Something if you had like a picture of, say, sand, like a desert, that's very uniform. And so that's also well suited to steganography. It could also make it easier to uncover with certain techniques, though. So we'll get into the techniques in a second here. Now, what kind of tools are there out there? There's a lot, okay? Like thousands of tools. S Tools is an old school um, steganography, basically for doing steganography on images. It's well regarded, but it is ancient. It goes back to Windows 95. Um, so I don't really have us use that one. There's MP3 Stego, which will let you work with MP3 files. So if you want to hide information in sound, there's Steg Hide, HIP, JP Hide, and a whole bunch of others. And so I don't actually use any of these. There's some other ones that I use for the exercise, which I kind of like and find interesting. But there's always coders who are coming up with new tools that you could use, just because it's a fun topic, you know. So how does steganography get used? Well, there's corporate espionage. So if you're trying to smuggle data out, that's one way that you could do that without being noticed. Terrorist cells, they do use this as a form of communication, and the way that they'll do it is they'll go to some long abandoned thread on the internet, and they'll just post images, you know, and the images have the messages embedded in them, and so Security organizations, they know about this, so they're, when we talk about people monitoring the web, they do that. They look for abandoned news groups and all that kind of stuff where all of a sudden messages are popping up, and then they want to see if there's any images or any kind of large files. They're interested in seeing if they can crack those, right? Child pornographers will use this to hide their own illicit content. Lots of other activities if you're a little paranoid and you don't want to get caught, right? Digital watermarking is also a kind of harmless type of steganography where you can just put your mark on, say, a photo that, let's say you're a photographer. Many photographers will actually watermark their files. So if somebody uses it without attribution or approval, they can say, "Hey, I know that you're using my file. I can tell because I've watermarked it, right?" They can use that for trademark purposes. Now, detecting steganography is a tricky game. It's not that easy necessarily, especially if there's encryption involved, but just in general. There's different ways that you can kind of guess that steganography is being used. And one, the general approach is called steg analysis. So it's just the different techniques that we use to figure out whether a photo has been doctored or played around with. Okay. It is, I will say though, it's hard to use. So many tools that implement steganography also will implement encryption techniques. So even if you suspect that a file has been stegoed, you then have to extract it, figure out how to extract it, and then you have to try and decrypt it often. Okay. So this is not an easy game. You could usually tell that files have been modified if you have an original copy and you can do a hash validation against it. Okay. So if there's a photo and this is like a stock image, um, you could probably locate that stock image and then you can just compare the hashes. And that's not absolute proof that the file has steganography, but it is an indication that you could look a little further and see what you can find. Now, there's other things that you can do which give you a better indication of whether steganography is being used. So, color frequency analysis on an image where you're not using the human eye, but what you're doing is getting statistical information about how color is changing within the image and whether that mimics natural settings, you know. And if there's some artifacts in there that don't kind of match natural transitions of colors, then a program can alert you and tell you, yeah, okay, well, statistically this is a little bit odd. Maybe you want to look at it. It's not a guarantee. It's just a hint in the right direction. Date, time, and size comparisons to the original may or may not help. Those are all fakeable. Okay. So it can give you a clue, but it's not a guarantee. It's just a clue. Signature analysis. In this case, you're not looking at the image itself in terms of, does it look weird? What you're going to be looking at is, did the tool that inserted steganography, does it tend to leave any traces of its existence? Okay. So some tools do leave uh, kind of patterns signatures that you can detect. And, if you're using NCase or Autopsy or something like that, you can write a plugin which will look for the use of that particular tool. Okay? That's kind of hit and miss, but that can be very helpful. That gives you a very good idea whether a file has been subject to this tool or not. Okay. Direct viewing of the file is really not the best way to do it. The human eye is very limited. So, your chances of noticing it, unless it's very poorly done, are rather slim. Okay. A hex editor, again, just relying on the human brain to figure this out. You might luck into something like that, but it would be a challenge. Okay. A next generation firewalls, I don't think there's any chance, honestly. I don't think there's much of a chance that that could be detected. It might detect the downloading of a tool, but it's not going to be able to look at an image and say, oh yeah, there's steganography in there. Okay. So really, you want to look for a stego program. That's the best and easiest way to know that this has been done. And so Ncase does have plugins that can detect that kind of thing. And there's specific tools which can do it, like Steg Detect or Xsteg. Those are freeware tools which um, can actually try and locate signs of signatures of the use of certain types of software. Okay. They are not complete by any stretch, right? So, as there are so many different versions of steganography out there, so many different tools, they only check for a limited number of them, and so your mileage is going to vary for sure. Now, some examples of legitimate use of steganography. A lot of printer manufacturers they use stego on their color printers. This was something that they worked out. This is in the US, but it applies to us too because a lot of our printers come from US companies. But all the printer companies, HP, Xerox, Epson, all of them, they've all agreed to put watermarks into their printers. And so any page that gets printed on a color printer has a little bit of information about what printer this came from. Okay. Little yellow dots are added to each output page, which can be read so that investigators can trace back, a page, a printed page, to a particular sold device, right? So they may not be able to narrow that down to a particular person, but they could narrow it down to a city that a product was sold in, you know? So this is done partly to, for things like forgery, but it can also be used to track down where a device might be located, so you can narrow down lists of suspects. Okay. Um, Now, if you want to avoid that kind of thing, so if you're a criminal and you don't want to get caught, don't use a color printer. Just use a black and white. That none of the black and whites have that characteristic. Okay? Now, if you are using a color printer, you can use blue light to actually look for the hidden data, and it'll show you there. Okay. Okay. So this exercise, it's longer than it seems because there's data embedded within the actual assignment. Okay. So what I suggest, you want to download this particular file, and then you're going to extract data out of it because it has steganography within it. Okay. So first you're gonna, uh, do part A and part B, and then as you extract more files, we're going to use those files because we have steganography within steganography within steganography, which is why I'm kind of showing this picture of the babushkas here, um, just as a bit of, just a bit of fun. Okay. I get the joke. That's good. Thank you. I'm glad you get it. So we're not just doing Stego, we're also doing NTFS streams. You can play around with that a little bit too. And then we do some lower level, like simpler types of hiding. So using the hidden attribute, for example, is one way. It's not a very good way, but it is a way to hide things. We do some registry edits so that you can hide a program or you can hide a drive, so that people can't see them even though they're there. So I'll give you an example here. Um, if I just go on to, let's just go here. Like I've used this, I have my C drive and I have my Google Drive, but I've actually got a D drive here, which is hidden. And I do that just to keep the family out of um, the work folder. I don't want anybody to mess with it. So there's a second disk here. I just make it hidden. So if the kids want to play games, they can play games on the computer, but they can't easily access data because they don't really know it's there, right? So I actually show that up here in this part of the exercise. You can actually set a registry value, which will hide a map drive. Okay. So make sure you get this done maybe by next class, by Wednesday. and then we'll release the Kraken, and you can do the last lab here for the course. Okay, get your groups lined up. I know a lot of you have pretty good groups. It seems like you work well together. I'd recommend you kind of just keep those. I think I allow a maximum of 4 members in the group. So, if you're just a couple people and there's a couple other people, you could merge if you like. You don't have to, but that's kind of the upper limit of what I'm good for coming up. So, do the exercise and figure out your groups before we get to the release of the lab. Okay. Questions? Okay. Have a good lunch. I'll be here for another hour, and then I'm going to go eat myself.